Welcome everybody. If you are just joining me, welcome to week 2 of the webinar series focusing on data to recovery, what we think is the best practice journey with Datamine's mining suites of softwares. This is week 2. My name is Hawken. I will be covering the from concept to resource model, building a confident geological model. A little bit about me, in case you don't know what I look like. I look 12 years old, but I'm actually 34. I have about 10 years experience in the industry. Prior to joining Datamine approximately 7 months ago, I was a senior resource geologist at a Australian gold mining company. So that's enough about me. Today, we're going to be focusing on the geology part of the mining value chain, but Datamine does actually have a whole slew of solutions going across the entire value chain, all the way from exploration to production, laboratory, and sustainability. Last week, we covered Discover with DeCarlo Aranza, and this week, I'm going to try to cover some of the stuff in geology, but noted that I'm only going to cover the Studio RM and Supervisor, which currently. So thank you if you're joining us from around the world, and good evening, good morning, or good afternoon to you. I am sitting here in Perth. What we will cover today, so from concept to final resource model involves a couple of different steps. I'm going to simplify it down and cover the geological interpretation, more specifically with the implicit wireframing tool in Studio RM. We're going to fill the wireframe produced from here with the blocks to produce a volume or domain model, as it's called in the industry. And then after that, we're going to look at the raw data, look at potentially coding and compositing the data in Studio RM to equalize the support for more samples. We're going to look at some top cut strategies. I'll show you how to do that in Supervisor, and then coding the actual top cut back onto the composite or the raw data, depending on which way you go down in Studio RM. And then we'll look at some EDA or exploration data analysis in Supervisor. Again, for a lot of you, I realize that will not be news, but hopefully in this process, I'll be able to show you some of the lesser known functionality of Supervisor. So we'll look at outlier analysis with our global top cut analysis, doing variography or the variogram model, and then we'll look at search neighborhood definition. Finally, once all the geostats have been done, we'll bring it all back to Studio RM. And I'm only going to cover the inverse distance and ordinary creek portion of the linear estimation, but just know that RM has the capability to do more. But owing to time constraint, I won't be able to show you everything. Otherwise, we'll be here for the next 8 hours. And then I'll show you the model validation, both visual and statistical. More specifically, the StatCom functionality in Studio RM and the model validation module in Supervisor. So in its simplest form, last week, we more or less covered quite a lot of this. This week, I'm assuming that we've completed up to this point of the resource estimation, that all data has been validated, that I've done my drill hole export, and I'm ready for geological interpretation. If you're unsure about drill hole validation, we have done multiple other webinars on it, or you can refer back to last week's webinar where my colleagues talk about some of the basic EDAs as well as the quality assurance processes. So I'm going to start from the geological interp all the way to the estimation portion. Note that I'm going to stop at validation because my colleague Roberto is going to talk about resource confidence and potentially how it applies to classification next week. So we're going to stop at the validation step. So that's enough babbling. Let's get into what we're here for. So if you haven't seen it before, this is Studio RM. I've got some things loaded. A little bit about the demo deposit. We are looking at a narrow vein orogenic style deposit with silver, copper, and what else is in it? Let's have a look. So we can have a look at that and seeing arsenic as well. It is on the side of the hill. The majority of the drilling is generally more or less east, west. And let's have a look at some additional features for validation. In Studio RM, you can bring in static exports of Geohole wireframe, which is what this Geohole importer is designed for. But at the same time, if you are using a industry standard database like Acquire, Fusion, or other ODBC, you can link them to it. In this case, I am just using a few CSV files. Due to time constraint, I'm not going to run this process because it's more or less the same all across the board. But I will show you this validation functionality where even if you are dealing with a validated data set, as a last line of defense, if you will, we can have a look at some of the things that Studio RM picks up as being problematic. So for these holes where there are no surveys at 0 degrees, at 0 meter, essentially no color shots, you can actually apply a couple of quick fixes to them whereby essentially the first valid survey will be projected back to 0, such that it will have a survey point at 0 to result in a correct desurveying. For these ones where Studio RM picks up as large dip or ASI curvature, as the Aussies and some Americans like to call dog leg in the survey, you can actually change the rules in here. So right now it's picking up any large dip and curvature changes as 10 degrees per 10 meters. You can actually change that, but I'm just going to leave that as is for now and let the quick fix do its thing. Now, one of the things that's, I'm actually missing a couple of slides, but sorry, what I didn't mention before, the relevance to JORC, the 3 underlying principles of JORC is transparency, materiality, and competence. Now, I'm not going to address competence because the competent person definition is well outlined in JORC, and it's up to yourself and your peers to keep you accountable. But what we can help with a combination of Studio RM as well as Supervisor is that we can help you produce a transparent workflow and help you produce a repeatable workflow such that all your interp and justifications are all your interps are justified, and if your assumptions are reflected in your final wireframe, hopefully. And if you have any QA/QC concern, one of the things with materiality is keeping a good record of it. So you can actually export your validation problems. So here, I'm just going to export that very quickly into my project folder. And it's going to show me a record. Oh, sorry. Just let it run for a second. And it will show me if it is running. Oh, seem to be slowing down significantly here. But you can actually export these as a separate CSV file. We'll just let it run in the background. We'll come back to it later on. Seems not happy at the moment. Oh, there we go. It is done. And what you saw on screen with the Geohole importer will be recorded here. So any of your problems with the surveys and what you did to fix them. So enough about that. That's just a quick 2 minutes last line of defense check. And as you can see in this particular data set, only the surveys are a little bit iffy, and we've addressed them, so they're good to go. And normally you'll just come back here to do your desurvey. You can do a couple of different things. If you are old school, or if you prefer a straight line segment, you can change your desurvey method to that. But majority of the industry, I believe, have moved to this radius of curvature desurvey method. So once you've run that, the end result is this. You have a drill hole with a bunch of different attributes in them. Right here, I'm showing geology. I can also show you my silver. So even before we dive into the actual interp, you can see that there are some pretty distinct trend lines or trends in the grade of silver, and that's going to be the focus of this demonstration. So the easiest way to build domains or domain mineralization wireframe is through the implicit wireframing tool. Here, I have a couple of different geology. I have an intrusion, I have a sandstone and a siltstone, hanging wall and footwall, and then in between them, I have the mineralized shears. For the purpose of this demonstration, I only care about the mineralized shears, so that's what I'm going to do. I'm going to come to my implicit modeling tool. I'm going to select my vein, and assuming your data is already well cleaned up and you can just model off your login data. I know a lot of people sitting at their office or sitting at home are going, no way, that will never happen. But if it does happen, if you have really good login geologists, this is what should happen. And we have a solution for that. So I'm going to select my drill hole. I'm going to point it to the domain of interest, which is geology. And I'm just going to batch build a bunch of wireframes for it. In this case, I'm only going to do the mineralization, so shear A and shear B. I'm going to essentially apply the same setting, same implicit modeling setting to all of them. And in probably a separate session, we can go through what some of these are, but I will mention that one of the distinguishing feature of our product in StudioRM and more recently our implicit modeling focused software that is Studio Geo is that the default behavior for boundary, instead of projecting your wireframe all the way to moho or to infinity, it's utilizing a algorithm called alpha shape, which is actually a well-known mathematical formula that essentially looks at the outermost edge of your data. So where I've been clicking, all these, the outsidemost edge of my data, essentially the algorithm is going to look at it and draw a series of concentric circles and then use that as my outside boundary. But enough about that. Let's look at what this model will look like for us. So I'm going to update my vein. Again, I am mapping my implicit wireframe to the geology. I apologize. It seemed like the Zoom webinar isn't fully compatible with my graphics card on this computer. So maybe some of the outputs are a little bit laggy, or it might come out as blank for some of you. If that's the case, I apologize, but hopefully a lot of you can see that. So there it is, as easy as that. In a couple of clicks of a button, I've essentially built a bunch of wireframes based on my logging or my intervals. Yeah, so that's all good and well. And as you can see, we have a few more options to do with pinching the boundaries. A lot of implicit modeling algorithms out there, ours included, will look at the last point of the input data. So then if you have an extremely thin extremely thin interval followed immediately by a really thick interval. Here's the example of it without the boundary thickness control. It's going to produce a lot of shapes that are really thick towards the edges of your wireframe. We know that in actual geological space, these cannot happen unless your wireframe hasn't been fully closed out. So with the boundary thickness control, that just allows us to produce a little bit more natural of a geological shape. So again, this is the ideal scenario where if you have a great control data set, you only have a limited number of logging data and your logging geologists are really good and really consistent. You review your data on the daily, you can do this. But for a lot of us, especially working in the exploration space, we oftentimes will resort to flagging in grades for our wireframe. And a few of our competitors have thought about that and produced some really good tools for it. So yeah, we can equally do that. To do that, first I'm just going to add a column for me to flag into, and that's just going to be called, let's just call it domain. And it's going to be an alphanumeric column. Um, Worth mentioning that essentially all Datamine files are a table that can be viewed in the Datamine table editor. So with that, I'm just going to give it a default value. I'm just going to call it unassigned, and it's going to have 16 characters in them. And hopefully that won't take too long. And with, let me just turn that off. I'll show my grade legend. Now I have a bunch of grades, but you can clearly see that there are two very distinct trend lines in there. So I'm just going to group them into something a little bit more usable. And to do that, I will, whoops, sorry, jump a step. To do that, I'm going to use my expression translator, and I'm going to cheat here and use a, whoops, oh no. Should have brought my OneNote beforehand. But yeah, essentially, I'm going to build a bunch of grade bins using the expression translator, or what we affectionately call extra. That is one of our most utilized command in all of StudioRM because of how utilitarian it is. So I'm going to look at my Pandora drill hole dataset, and I'm going to spit out a new file called dump. Doesn't really matter what the parameter is at this point because extra is essentially a twofold process. But this second part is where I am going to do some of my magic. Essentially, I'm going to group a lot of them into grade bins. And the syntax hopefully is quite easy to understand. A lot of it is quite similar to SQL if you are familiar with that programming language. But essentially anything with silver that's under 2.5 grams, I'm going to call it waste. And anything between 2.5 and 40 grams is low grade. 40 to 620 is medium grade. And anything above 620 is high grade. So I'm going to execute that. Hopefully that's run it for me. And I'm going to drag in the new file. So this process generates a new file, and it's still thinking about it. Oops, I've done an oopsie. Sorry, let me redo that. So let's do DOM instead, and make sure I select alphanumeric instead of numeric this time. And let's do on the sign. Go OK. Unload that. So now if I query my data, I should have DOM unassigned. And let's just run my expression translator again. This time I should be able to hit restore. And I'm going to replace the file that I previously tried to do. Instead of domain, it's going to be called DOM now. And hit execute. Oh, alpha value. Joy. Well, I troubleshoot this. Hopefully it won't take that long. But essentially what the file should look like is something like this, but with the domains coded into them. Perfect. So luckily I've prepared something else after. We can actually look at a different slightly different data set. I'm going to skip a step just because I don't want to hold people up. My apologies. Slightly unprofessional, but hopefully we don't hold things up too much. But yeah, we're going to go back to the implicit modeling and we'll look at some of the functionality to go with it. So instead of just building the vein, I'm going to first assign certain samples into a different column. And excuse me. So there we go. So if instead of the sandstone, for example, and I want to assign it into my shear B, I can actually just use my swipe selection tool. A lot of people don't know that this swipe selection tool actually exists, but it has actually been in the Datamine ecosystem for quite a while, and you can change the swipe width by using your scrolly bar. And all I'm going to do is just hit assign into my fields, and that's going to change the encoding. And yeah, so that's all right. For a lot of these functionality, Studio Geo actually produces it way better, and it produces a much nicer workflow for it. So I encourage you to contact my colleague Joe White, who is our lead Studio Geo consultant for some of the functionality. We're going to move on to compositing. So because a lot of my domains are already coded in during the flagging process, I can actually just composite directly inside the coding of my drill holes. So that's what I'm going to do, and I'm going to use the composite tool. Worth noting that you actually have an interactive compositing tool in here as well, and that just allows you to quickly query the downhole, the average downhole grade of any interval that you choose. Alternatively, when you are using the edit attribute, you have the option to show averages across multiple things. So if I'm using the swipe selector, I can select multiple things and then it will show me the average grade for them. But yeah, something reasonably handy. But in this case, I'm going to use the composite tool, or CompDH, as a lot of you are familiar with it. And I'm going to composite inside a drill hole that I had previously flagged in the domain already into a composite file that I'm actually showing you now. But yeah, due to some technical difficulties, I can't get it to work right now. But if you're interested, please hit me up and I'll show you on a separate demo. But I'm just going to composite inside the field called geology, and I'm going to composite them to 1 meter interval and at a minimum comp length of 0.5. Now, I actually had a tool that I failed to show you earlier to figure out the average sample length and the minimum sample length, but yeah, we'll let that run and I'll show you that right now. So when you select all the drill holes in the scene, I'll go back to the regular selection tool, or I can actually do that through here, just uncheck that, or with the hotkey SMT. I can select all my drill holes and then go QMD, or query multiple holes, and then it's going to show me the maximum and minimum sample width. So with my raw input, where I've had it worked, I've flagged in multiple things into it. Yeah, of course it's not going to work now because I didn't actually flag it into it. But the raw, let's say, look at the raw data, for example. The raw data has an average sample length of 1 meter and a minimum sample width of 0.5. And that was the setting I chose to composite my sample in. So now when I query my composited samples, it should show that my samples are now 1 meter and minimum is 0.95 because it's been spread out evenly inside the mineralization domain. And this is probably a good point where I can bring this file into Supervisor for my initial round of geostat analysis. To bring things into Supervisor, I will just chuck that up in here. You have a couple of different ways. The easiest way is to just simply drag and drop my Datamine file into it. RM3 users will note that .dmx file currently isn't supported, but we're working on that very hard in the background. But for the moment, just make sure that you're reverting back to .dm format in order for it to work with Supervisor. But yeah. So what I've done here is I've just drag and drop the composited file into Supervisor. And as you saw, it was as easy as that. I need a domain and an assay. And this is quite important for the downstream process because the input analyte on which I will do my variography on will be what I reference in the estimation step. So once that's brought in, I have a couple of different things that I can have a look at. And this is the example that I've prepared earlier. So with the raw sample, I have shear A where the the grade distribution is roughly that. And I can actually run a global top cut analysis. So at the moment I've got my top cut applied. I'm just gonna clear my top cut so you can see the grade difference. But with top cutting strategy, everyone's mileage differs, but right now I'm just gonna show what I would normally do with the disintegration method. So with this distribution, you may argue that I might not be able to achieve good stationarity, but for the purpose of this demonstration, even though my CV is 2.6, which suggests mixed population, and I can see the multiple peaks, I'm actually just gonna run a quick ordinary creek on it. And with the disintegration method for top cut strategy, when I look at my cumulative metal, I can see that there's a clear point of disintegration with the distribution. So 6400 is where I'm going to go. You can also choose other points as well. And if you are linking the top cuts, it will link all your fields together. So I'm going to apply 6400. And when I apply my top cut, you should see that the log histogram has changed slightly. I've lowered my CV a little bit, but top cut is really never about dropping the CV, but about removing the outlier. So now that I've determined that 6400 is what I want to do with my top cut for shear A, I can do the same for shear B. So just to look at what that looks like, that's what it looks like. So now that I've determined my actual top cut, I can then top cut my samples, which are composited, again, using my extra statement here. So I'm not gonna run this one just for time constraint. I realize we're running a bit short on time, but so we're gonna look at the composite and we're gonna produce a new file called Pandora.com TC. The actual file name doesn't really matter, but the example top cut will look something like this, whereby if I'm inside this particular domain, I'm gonna produce a new field called AGTC or silver top cut, and it's gonna return the value that's either return the lower value that's either the original value or 6400, essentially top cutting. And there are a slew of other numerical functions that you can choose to help you achieve other things. So what that will look like is something like this. And if you bring that particular file while that's loading in the scene, if you bring that particular file back into Supervisor, you should see that the maximum sample is now 8,000 instead of whatever it was before. And that's because the top cut is not applied to shear B. And now that we've achieved our top cut and removed outliers, I can do my variography. Variography normally starts with defining the maximum continuous continuity fans. To do that is quite simple. I simply right click on the domain. I'll add my horizontal continuity fan, and then I'll add my cross-strike continuity fan, add my dip plane, and my continuity model, and finally all my variogram models. So, and this is where you'll come in and utilize some of the automatically calculated variogram for you to determine the best direction for continuity, and similarly with the variogram modeling. It's very interactive. You can drag a variogram to suit whatever you wish. So again, in the interest of time, I'll show you one that I prepared earlier, and that looks something like this. So with the downhole variogram, because I'm compositing to 1 meter, I am showing a lag of 1, and it's showing a relatively high nugget. And being that it's a high nugget ore body, I have also chosen to do a back transform model for this particular variogram model. And when you do a back transform model, not only do you have this continuity model up here, which is in the normal score transform space, you can also report the back transform model, which you'll notice that the nugget has increased quite a bit when you back transform away from normal score. But all I wanted to show you is that you can actually see all 3 directions simply by holding down shift. Hopefully you can see that shift, and I click that, and we'll see my my downhole and my principal axis, my semi-major and my minor axis. And that's essentially my continuity model. And you can also visualize it in 3D. Hopefully this will work. Normally I have some problems with the graphics card when I'm screen sharing. Yeah, it's worked to some extent. So here I'm reporting a very shallow north plunge, and that's going to be basically my search. Speaking of search, we also have the kriging neighborhood analysis tool. And when you have a continuity model build, you can add that by right-clicking on the continuity model and go K&A. So here's one, again, what I prepared earlier. You can input a couple of different block sizes to determine whether or not which one is more appropriate for your drill hole spacing. And then with K&A, I know there's some conjecture with K&A out there. Some people are big fans of it, some people are not. That's up to you, but I can use that to guide my search neighborhood definition. So in this case, I'm going to select somewhere between 4 and 14, where the kriging efficiency curve is starting to smooth out, but not so much in the plateau that I am smoothing out my estimation too much. And once I've selected that and I hit refine search, it's going to show me a couple of different scenarios where Supervisor thinks that might be other continuity models that may better suit the data. In this case, the average kriging efficiency are quite similar across all of them. So I'm going to say that's probably pretty good. The normal workflow at this point would be to right click on the back transform model for both of them, and then you can export it as either a CSV file or a Datamine compatible file for use down the line. But with our advanced estimation module, you don't actually have to do that anymore. So something I didn't get to show you earlier was the building of the wireframe with the swipe selection, but here's one that we've built from the batch process, referencing the geology only. So we'll use that to produce our block model. So I'm going to fill the wireframe with blocks now. And to do that, I'll go to Model, Fill Wireframe. And again, if you are trying to replicate repeat the same process a bunch of times for materiality reason to produce your draw compliant resource, you can actually save your scenarios to make sure that you are using the same parameter for filling every time. So I'll do that here. So here we go. And I was going to show you how to build the prototype as well, but we are running a bit short on time. So I'm just going to show you one that I've built. The prototype in Datamine is essentially an empty model that specifies the parent cell, the model extent, etc. So this is the scenario that I've used before. The topography, which is this file here, will be used to build essentially the waste model, and I can specify the density in here. And then for my geology model, it's going to reference this set of wireframe, and the encoding of the blocks will be done with the geology attribute from it. So this zone field geology here is important because that's what will be coded into the blocks. And I'm going to call that Pandora DOM-mod, and I can optimize my subcells. If I hit run, it's going to produce a block model that looks something like this here. And I can, once it loads, I do apologize, I'm skipping ahead because we are starting to get quite late on the hour. So if you have any questions about any of these processes, please feel free to send me an email down the track. And here it is. So my blocks have been filled inside my domain, and some of the domains are a little bit ugly. I can go back and change it, refill it for estimate. But now that I have an empty block model and set of drill holes with variography loaded, I can then commence with my estimation. And the best way to do that, particularly for linear estimation, is through our advanced estimation module. So with advanced estimation module, it will essentially guide you through the selection of the data, selection of the prototype model or the input block model. Of course, it's decided that it wants to go a little bit slower, being that it is getting closer and closer to knockoff time for WAers. But while that's loading, once you have successfully produced a block model, I'm going to skip ahead here. You can actually bring that block model back into Supervisor for visualization and validation. So Supervisor does take block model produced on Datamine as well, and the import of it is very similar to drill hole data in that you have to specify domain. In my case, it's assay domain, and then you can run the model validation function, which will draw a lot of very useful plots for you. So swath plots in the X, Y, Z, and the strike and cross strike direction of the continuity model that you define, and then also with the tonnage grade curve. And with the tonnage grade curve, not many people know this, but you can actually perform a global change of support as well to validate your theoretical tonnage grade curve. If you have any additional questions or you want to learn more, please contact Oscar Rondon, our in-house supervisor expert. So now this is done. Perfect. This is what advanced estimation will look like when you first come in here. It's going to ask you to set up a new scenario. I'm going to call this one demo scenario. And I'm going to select my samples, which will be the top cut version of my composites. So I'll select that. It should automatically map in the XYZ for me because that's what they usually are in Datamine format. I'm going to select the analyte. This is very important because for the link between supervisor and RM to work, my variography, which was done on AGTC rather, needs to match the input analysis method AGTC in the advanced estimation module. In the scenario setup, you also have the option to choose whether or not you want to use supervisor for variography and KNA. You can do both of these in just RM alone. So when I take this on and off, it will just hide the corresponding portion in RM. In this case, I'm going to import it directly from supervisor. Let me just check that nothing's imported right now, so I don't have any variogram. I'm going to find my supervisor project and just hit it with import. note that every single continuity model or every single variogram model essentially in supervisor of your choosing will be imported. So just make sure you have some sort of identification for them if you want to use this functionality. It's going to show you that import is successful. And now I will have some variogram models ready to be used for down the line. So back to defining my samples. I'm going to run my estimation in the domain geology. And some of these pertains to other settings like BHID, the froms and tos, if you have any core loss or loss samples. If you want to do soft boundary, this is also where you would define it. And then you can define a bunch of bivariate stats. The prototype model is the empty block model that we filled in earlier. So the DOM mod. And then this is also where you get the opportunity to define a model of your choosing. So the model name of the final output. If you are doing dynamic anisotropy, there are some additional steps involved, but yeah, we're not going to do that owing to time constraint. And here is where you define the estimation. I'm just going to clear these and then go from start. So I'm going to do a ordinary Krige version. You have by default four linear estimation methods to choose from: ordinary Krige, simple Krige, nearest neighbor, and inverse distance. Ordinary Krige is right here and by default, and a lot of us like estimating into the parent cell for geostatistical reason. You also have the option to reset any negative kriging weights to 0. Whether or not that's statistically correct, your mileage might differ. I won't try to answer that for you. That's up to you and your resource team. So I'm going to estimate with AGTC and into these two zones. The field setup, the input is going to be AGTC, but the output in the final block model, I'm going to call it OK. I'm going to spit out all my estimation quality matrix. Some of the most noteworthy is, of course, kriging efficiency and the slope of regression. So that's the first of the two estimate setup. And I'm just going to set one up for inverse distance quickly. So I'll click back into it. Inverse distance, I'm going to choose a power of 2. You can do 3, 4, 5 until you get to a point where your reconciliation comes good. Sorry, I'm joking. Please don't take that very seriously. But yeah. So this is inverse distance, and I'm gonna, whoops, close that's unhappy now. ID. These are just the fields associated with the inverse distance estimation quality. And I'm only going to do those. And then when it comes to the variogram step, you can just assign the variogram that you have from the import directly into your estimate. So I'm going to assign 1 to 1 with 2 to that one. So that refers back to my 2 variogram model. This one is 1 for shear A and 2 is shear B. And actually, that should have come up. That's all right. We'll run it as is. And here, you actually can auto-calculate search volumes for the variogram. And I've done that earlier already. So I'm going to assign the same search to the inverse distance as well as the ordinary Krige for A and B, just so then we can, just so that we can compare them later. And once that's done, all you have to do is click estimate, and that's going to run your demo model for you and also spit out additional file called sampout that you can interact interactively. So again, because we're running a bit short on time, the penultimate output is going to look something like this. where this is my resultant block model, and that's the input for analysis. Of course, I am in clip or section view. So this is where I can do my visual validation here. I can step forwards and backwards, make sure that my drill holes are roughly aligned with my model estimate grade, but I can also do a quick statistical analysis with my statconc command, or the model versus sample command. Just make sure that if you are comparing ordinary creek samples, ordinary creek estimate to samples, you have a decluster set of data instead of just a naive mean. Otherwise, you won't be comparing apples to apples. So I am going to show, I won't have time to do the declustering, unfortunately. I'll just compare it directly to the raw mean. And here I'll specify the model grade, which is AGOK, and then my sample grade, of course, is AGTC. And I'm going to automatically spit out an Excel. Had you done the declustering with our decluster command, which is you can find through sample analysis, decluster, or with a simple declustering, you will use that for this particular process. But it is now 10 to 5, so I'm going to skip that. Just know that this is not entirely comparing apples to apples, because I am comparing, it's not doing it quite correctly. Let's have a look at this one here. Of course, the more you rush, the more things go wrong. All right, let's try to do this properly. We're going to decluster our sample set. And const tc. And I'm going to, instead of producing the actual decluster set of data, I'm going to assign some weights to them. I'm going to assign my XYZ to, X, Y, and Z. And the parameter is going to be declustering with method 3. And I'm just going to use a 25 by 25 by 25 grid. That's going to give me the decluster sample set. And then I can use my statconc command to compare my decluster sample set back to the model. So let me just double check that that has worked. So with the decluster command, it should spit out the decluster weight while retaining all the other attributes as well. Equally, you can do declustering in Supervisor. So in Supervisor, when you're doing the model validation step that we vaguely skipped forward before, just make sure that you are comparing the decluster sample set to your model grade. And to do that, just right click on the domain and add a component called decluster. I've already added already, so I can't add it again, but yeah. And then here you can link them by different axes to select the lowest mean, for example, to compare against your model value. So that's your statistical model validation in Supervisor. And hopefully the last thing I'll do is to get this one working in Studio RM. So go to model against sample. Again, I will select this time I'm going to select the one that I've done earlier, which is the one with the weights. Oops. and statcom 2. Select my model grade, which is AGOK, AGTC. Oh, that's what I didn't do earlier. I didn't select my domain. Sorry about that, guys. So once that's done, you'll get this very useful table called statcom, and it will give you the oh, great. Why is that? Statcom. Yeah. I think in the interest of time, I'm going to leave it there. Sorry about that. And in theory, what you should be getting is the model grade against the sample grade against the model grade. And had you had a declustered set of samples, you'll have the mean of the declustered set of samples as well. So yeah, unfortunately, it's a bit of a weird one, but yeah. That will bring us to the conclusion of this demo. Sorry about that, but I guess you still have the model validation to go towards in Supervisor. So thank you.